Yes friends, so we are doing question number 9. Okay, so here the time taken by the train to cross the bridge, to cross the platform is 20 seconds. That is the answer. Okay, so this is the answer here. Time taken by the train to cross the bridge. What we did, total distance traveled is length of the train plus length of the platform divided by the speed of the train. The speed of the train is this. Okay, so in that way also we could write it, but I have just solved it. 20 seconds taken by the train to cross the platform. Alright, this is question number 9. Now let me take the last question, which is also very important. Now we have to convert the speeds into kilometer per hour. Meter per second is given. Then what I have to do? Simply, here we are going to talk about. Now question number 10, let me take what I will say. Question number 10, what is given to us? And so different parts are there, I think. Express the following in kilometer per hour. Now in kilometer per hour, you have to convert the speed of the train or speed of anything. Here speeds are given. So when we convert the speeds into kilometer per hour, if it is given in meter per second, then we have to reverse that 18 upon 5. We have to multiply that meter per second speed by 18 upon 5. Why that we clarify. Okay, what is given to us? The speeds in kilometer per hour. Sorry, the speeds given in meter per second. The speeds in meter per second. What is given to us? Meter per second. The speeds are given in meter per second. To find the speeds in kilometer per hour. Kilometer per hour, or we can say kph. Speed in kilometer per hour or kph, or in kph, right? So speed in kph we have to calculate. The speeds given are in meter per second. What is given to us? Speeds in meter per second. To find the speeds in kilometer per hour, that we have to calculate. So this is given. What is the first part? So in A parts, let me take solution. First is part number A, section number A. What is given to us? We are given here the speed here is equal to 10 meters per second, 10 mph meter per second. This is 10 meter per second. Alright. Now if I have to just convert this into kilometer per hour, then 1 meter equal to how many kilometer? 1 meter equal to how many kilometer? 1 upon 1000. Okay. This is 10 into 1 upon 1000. This is 1 meter. Since 1 meter is equal to 1 upon 1000 kilometer. Try to understand. So we can say 1 kilometer is equal to 1000 meter. Therefore 1 meter equal to, divide this, take 1000 to the denominator of kilometer, that is 1 upon 1000 kilometer, right? 1 meter is 1 upon 1000 parts, 1000th part of a kilometer. That is how this meter is written as 1 upon 1000 kilometer, right? Divided by, now this is second per second. Now 1 second is equal to how many hours? This is 1 upon 3600, 60 into 60. This is in hours now. Okay. In hours. 1 second equal to 1 upon 3600 hours. That means 1 second is 1 upon 3600th part of an hour. 1 hour is equal to, we can say, 3600 seconds. Therefore 1 second is equal to 1 upon 3600. So in that way This is 1 upon 3600. 1 upon 3600. Right. It will give us 10 into 3600 will come in the denominator, in the numerator. It's 3600 divided by 1000. This is now in kilometer per hour. Kilometer per hour. Converted. Now this 200, this is 1000, sorry. So 2 zeros are cancelled out. 2 5 and 2 18 times. This is 10 into 18 upon 5. So whenever we have to convert kilometer per hour, meter per second into kilometer per hour, that is to be written as so multiply by 18 upon 5. So this is 18 upon 5 we have multiplied. How we obtained 18 upon 5? That I have clarified that 1 meter equal to 1.1000 kilometer, and this is 1.3600 seconds. Sorry, this is in hours, because 1 second is equal to 1.3600 hours. Okay, so this is in the hours, now converted into hours. This is in hour, kilometer per hour. Alright, so this is totally we have solved, because 3600 will come in the numerator, and this is upon 1000, because when A upon B is divided by C upon D, and in place of C we have 1, in place of A we have 1, B is 1000, this D will come in the numerator. How? Because A upon B when divided by C upon D, so this division sign is changed into multiplication. A upon B into this ratio is reversed. D upon C it will be. It is A into D. A into D. A is 1. D is 3600. So 3600 into 1 divided by B into C. B is here 1000 and C is 1. So 1000 into. This is how we have obtained this 3600 divided by 1000. Then we just change it. 2 zeros cancel out. 36 upon 10, that means 18 upon 5. Okay, this is 5 to the 10, 18 to the 36. So this is 36 kilometer per hour. Try to understand. The 36 kilometer per hour is the final speed of this given speed in meter. Given speed was in meter per second. Now it has been converted to kilometer per hour. The unit has been changed from meter per second to kilometer per second per hour. kph. Alright. So this is how we have to calculate. This is the first part here. A. The answer is 36 kilometer per hour. This is the answer. First answer is 36 kilometer per hour. So 10 meter per second is equal to 36 kilometer per hour. Alright. This is the first part of this. Second part, let me now take. The second part is what? Now I'll do it directly. Just multiply by 18 upon 5. In case of meter per second is converted into kilometer per hour, you have to just multiply by 18 upon 5. If kilometer per hour is converted into meter per second, then 5 upon 18. Just reverse of that ratio. B part, we are given here speed is, second part is 50 meter per second. So this is equal to 50 into 18 upon 5 kilometer per hour. kph I write, let me take kilometer per hour. Okay. So 18 upon 5, 10 times 50. So 10 into 18 is 180 kilometer per hour. kph. Okay, so this is second part of this question number 10th, second part. 50 meter per second is equal to 180 kilometer per hour. Alright, this is the answer here. Try to understand. Okay, so this is the process of converting meter per second into kilometer per hour. Always this, just try to understand how 18 upon 5 that I have already explained, that in place of 1 meter we have to write in kilometer. So 1 upon 1000 kilometer divided by 1 second is equal to 1 upon 3600 hours. Okay, then 20,600 will come in the numerator, divided by 1000 will give us 18 upon 5. So that is part number B. Now let me take part number C. What does C say? Now in C, speed given is how much? 150 meter per second. Okay, 150 meter per second. Therefore, this is equal to 150 into 18 upon 5. This is in kilometer per hour. Kilometer, let me write kilometer per hour. No problem. In this way also we can write 5, 3 is 15, 30, 18, 3 is 54, this is 540. Here speed is converted into kilometer per hour. This is kph or kilometer per hour. This is 18, 3 is 54, 540. 540 kilometer per hour. In that way also we can write the unit. This is kph, or just write 540 kilometer per hour. Alright. This is how we convert speed when it is given in meter per second into kilometer per hour by multiplying by 18 upon 5. Just multiply by 18 upon 5 the given speed, which is in meter per second, convert it into kilometer per hour. We have to multiply by 18 upon 5. And if the speed is given in kilometer per hour and if it is to be converted into meter per second, then we multiply by 5 upon 18. Just reverse of this. This is in question number 2. Question number 2 we have already done this. Okay, this is just reverse of that process. Simple. This is the answer here. So this question is 540 kilometer per hour. This was the answer here. Now D part, which is the last one. Last part of this is, now D part we are given 40 meter per second. So speed here is given 40 meter per second. It is to be converted into kilometer per hour. So what is that? This is 40 into 18 upon 5. Just multiply by 18 upon 5. Now this is in kilometer per hour. kph, this is 5, 8 is 40. 5, 8 is 40. 18 into this, 8, 8 is 64. 4, 6 carry, 8, 1 is 8 and 6, 14. So 144. 144. With 5, 8 is 40. 8 into 8, 64. 4, 6 carry, 8, 1 is 8. 8 and 6, 14. So this is 144 kilometer kph. Answer. Okay, this is the fourth answer here. What we have done up to now, what we have understood is speed. What is speed formula? Speed directly proportional to the distance, because distance is increased, speed will be increased, or distance is more, I mean distance is more, then speed will be more. Time is, if constantly, time is constant. If distance is changed, distance is increased, then speed will be increased. If time is constant, if distance is decreased, then speed will be decreased. So distance and speed are directly proportional. Okay, or direct variation. Speed is direct variation. Similarly, if time is constant, then if distance is constant, then time and speed are directly proportional. Time and speed. Because if time is increased, or if I talk about speed, so speed is inversely proportional to time. If time is increased, then speed will be less. If time is decreased, then speed will be more. Okay, so speed and time both are inversely proportional, or there is inverse variation in time and speed. If speed is more, that means time is less. If speed is less, then time is more. That is inversely proportional. This we talked about. Okay, and then formula, what is speed equal to distance upon time. Okay, and distance is equal to speed into time. From this, time can also be calculated, distance upon speed. These formulas we talked about in the beginning. Then we talked about how to convert meter per second into kilometer per hour into meter per second. These two processes. Then questions: average speed. What is the average speed? Total time, total distance traveled divided by time taken. Okay, so total distance traveled or total distance divided by time taken. Total time taken. That is how average speed is given. So I have questions based on average speed and simple speed to calculate, and then conversion of meter per second into kilometer per hour into meter per second. These are the topics which we have discussed and questions we have covered. And if late or speed, okay, if the person is increasing his speed and he is reaching in time or on time or more time, whatever, but that question was the time was added up. If it is late first by one speed and the second speed is given, or the person has reached 20 minutes before, that means that the difference of the time is added up. So 15 plus 10, suppose 10 minutes. Initially he was late by 10 minutes, then he reached 15 minutes before. These two times are added up, and the difference of the two speeds is to be equal to this time taken. Okay, so difference of the time calculate from the two speeds. If distance is same, x upon suppose p, and second time taken is x upon q. The difference, whatever the more or less is coming, the difference of these two, if speed is more, for example, in the denominator, then the time taken is less. So this value will be subtracted from the bigger time. That difference equal to sum of those two times. Okay, that is how we solve the other questions. That a person, for example, a worker reaches his office 15 minutes late by walking at 4 km per hour from his house. Next day he increased his speed by 2 km per hour. Then he reaches in time or on time. Now in this case only the 15 minutes is the difference. Okay, 15 minutes equal to 15 minutes. Difference of the two times, we have to calculate time, distance upon speed, then whatever the speed is, time taken is more, that from that we have to subtract the lesser time. So that will be equal to 15 minutes in that situation. Just we calculate that what is the distance of them. So I think we have to find the distance from his house to the workplace. That was the question we found out the distance. Alright, these things we have discussed about. The next lecture series I'll talk about the lecture series, because now we are taking more than one lecture. Okay, because divided into A, B, C, D groups. So this is series of lectures. Now these questions, time and distance, very important questions are most of the exams are they are just repeating. The questions based on time and distance, time and work, time and distance. Now the questions based on time and distance will be divided into different things. Questions based on streams, questions based on trains, etc. Train and streams, right? So that we will talk about. Streams and boats, etc. How boats are traveling. So distance covered by boats, distance covered by streams, etc. Those questions are also very important. So that also we will discuss about. Then the relative speed. What is the relative speed? Questions based on relative speed, they are also very important. Questions based on time and distance are so important that every competitive examination is repeating the questions. Giving the same question. 10 type of questions to come in. This important topic is being discussed today by me. Okay, this has been started. I'll take some more lecture series also based on the same topic. Okay, other topics are also left. Relative speed is left. Questions based on that is also required, and some more questions based on this, because a lot of questions are here. Thousands of questions I have collected from the students' queries, because students are asking regarding this. Concepts are to be clear, that what is the distance traveled to be and how much time taken and distance traveled, etc. So distance, in case when a train is crossing a platform, crossing a man is turning, man has no distance or nothing is to be crossed, only length of the train is to be crossed. In that situation, the man is to be crossed by the train, then the train has to cross its own length only. Platform is to be crossed, then length of the train plus length of the platform, both are to be added up, then that length is to be covered, then we say that train has crossed the platform. Okay, that is the concept of this one. Okay, then see you in the next lecture series. Bye. Till then, see you then. Okay.